Denodo is a leader in data integration and data management. We use a modern approach called data virtualization, which is a real-time data integration and data delivery approach. Global companies across the world have successfully used data virtualization for projects such as Agile BI, cloud data integration, data lakes, and also data services, and you can benefit too.
Good afternoon, everybody. Welcome to the final session for today. This is track 5 and leadership in action, lessons learned, success stories. My name is Bob Audette. I'm a partner of data management at Guidehouse. Today's session is going to be focusing on data mesh with data virtualization. And data mesh is getting a lot of press these days. And this session is really going to focus on a few key things, which is, what is data mesh? How is it different than some of the other architectural patterns and models that are out there? And how do you really get started with data mesh? A couple logistical things. The session will be recorded. It'll be available through Wahuva afterwards. 3 months from now, you can access this through the MIT CDOIQ YouTube channel. With respect to questions, for folks that are in the room, please raise your hand. And also, don't pose your question until you have the mic in your hand, because the people that are online will not be able to hear your question. For those online, please use the Wahuva app to pose your questions. For those in the room that don't want to pose their question, using the mic, feel free to use the Wahuva app as well. Now I'd like to introduce our speaker, Paul Moxon, Senior VP of Data Architecture's Chief Evangelist at Denodo. And a couple things about Paul, and he'll certainly fill in gaps, but he works with customers really to help them understand the benefits of data virtualization, data mesh, and advise them really on how the Denodo platform can really help them solve this particular problem. Over 30 years in helping different organizations with enterprise middleware technologies, leading software companies. He has a bachelor's degree in business administration from Northumbria University in the UK. So with that, Paul.
Okay, thank you. Thank you everybody for being here. Thank you everybody who is online as well. The introductory video was a bit scary because that was my chief marketing officer. I didn't actually expect to see that. One other thing I will add, because everybody in the room being Bostonian will actually appreciate this. I live in New York. I'm a Red Sox fan, and it's the worst place to live for being a Red Sox fan. Okay, so we're going to talk about enabling a data mesh with data virtualization today. This is actually what we're going to cover as we go through the actual topic. We will talk about the traditional approaches to data management that we've been using for the past 30 years and we're continuing to use today, how they've evolved a bit, but still some of the challenges that we face. Then we'll look at what is data mesh and how is it different from these traditional approaches. And then we'll look at how you can actually start to build a data mesh using data virtualization as the foundation technology. And hopefully then you'll go away enlightened and everything. And if you do have any questions, obviously we'd like to take the time to answer them as well. Now, for maybe 10 years or so, we've been changing the way that we manage data and deliver data to the business, to the users who actually want to use it to make decisions, take actions, etc. We've moved away from using a traditional data warehouse with data marts. We've added in constructs such as data lakes, data hubs, now data lake houses, and lakeshore marts, and all these other acronyms that you can think of. But the basic idea is still the same as it was for the past 30 years. It's still what I call business as usual. We are copying data. We are copying data from the sources, whether they're applications, databases, etc., that we're using to run the business. We're copying the data, we're building data pipelines, we're copying the data into a central repository. It used to be a data warehouse. Nowadays, it's more likely to be a data lake or a cloud data warehouse. We're then processing that data. We are going and applying business rules. We're transforming it. We're cleansing it. And then we're creating fit-for-purpose data sets so data analysts and data scientists can come and do their things. We used to do this with data warehouses. We built data marts. So nothing's really changed in the past 30 years. We're still doing the same thing. And so for some reason, we put the word cloud there and we think it's magically going to work. And somewhere in there's Einstein's definition of insanity, etc. Data mesh actually changes that. It changes the way we manage the data. It changes the way that we own the data, the responsibilities for the data. So this diagram you see on the screen looks very complex in its own right, copying data into a central data warehouse, and then go and copying it, transforming it again so people can actually use it. If you drill into that, it actually gets more complex. In each of these data pipelines, we're using different tools, different technologies. We may have ETL for doing the bulk load into the data lake or the data warehouse. So tools like Glue on AWS, Data Factory on Azure, Matillion or something like that. We may be having streaming data, so we might be using Kafka or Kinesis to ingest the data. We've got tools to orchestrate all of that, tools for connecting to on-premise applications like SAP or Oracle E-Business Suite. And then we need to have the engineers to actually go and build and maintain those data pipelines. So it's very, very complex. And like I say, we've been trying this for 30 years. And we magically think it's suddenly going to work because somebody says cloud. And as my wife told me, cloud just means somebody else's computer. That's all it means. It's the same technology. Data mesh looks at data and it says data is going to be distributed. But data mesh is more than just a different way of accepting data is distributed. There are some organizational changes in there that are fundamental to data mesh, and it changes how we actually think of and manage data. One of the challenges that Zhamak Dehghani pointed out when she came up with the concept of data mesh was we have what we call a knowledge gap. And if you look at the diagram we have here, on the left-hand side, you have domain experts. These are the subject matter experts who understand the data from that domain. A domain can be a business unit. It's an organizational unit. It could be a department like HR or finance or logistics or manufacturing. It could be a business unit in a different geography, but they understand the nature of the business. They understand that domain, that data. They understand how it's defined and how it should be used. So we call those the domain experts. In the middle, you have tools experts. These are the people who build the data pipelines to ingest the data from the domain, from the applications and databases in that domain, into the data warehouse or the data lake, where they then go and process it, they cleanse it, they apply business rules, they transform it, and they create the fit-for-purpose data sets to be used by domain experts. So we're going from domain experts to tools experts to domain experts. And in that middle, we lose knowledge of the data. This is not to say that the data engineers are bad. They were employed because they are tools experts. They're experts in the tools that they use. They are not experts in the domain itself. So again, data mesh addresses the knowledge gap so that we don't lose that critical knowledge when we're going from the source data to data being used for analytics. We're not losing that information. So what is data mesh? Data mesh is built on the concept of organizational units called domains who take ownership and responsibility for their data. They are the experts in that data. Like I said before, it could be finance, it could be logistics, it could be facilities, it could be manufacturing. They understand that data. They know how that data should be defined, what it means, and how it should be used. So data mesh pushes the ownership of that data onto the domains. They know the data, make them own it, make them responsible for the quality and the accuracy of that data. The domains deliver the data through something called data product. A data product means that they will deliver the data conforming to agreed upon standards, agreed upon protocols, etc. The data will be searchable, discoverable, usable by the other domains. So the domains, in some ways you can think of this as going back to service-oriented architecture. I will deliver a service to you. In the old days, it was through an API. How I deliver that service, you don't care, but you just get that conformity of, if I connect to this service, I know what it does. We're doing that concept with data mesh and domains. We're now delivering data products that you can find, you can use, you know what it looks like, you know how it works. Agreed upon standard protocols, formats, etc. Predicate amongst this as well is there is no need to centralize the data. The data can stay in the domains. It's made available for you through these data products. And that's how you get the data. We don't have to copy it into a central repository, a data lake, or anything like that. So let's have a look at the 4 key attributes of a data mesh. First of all, there is domain. This is an organizational attribute about domains. So we're moving away from the idea of centralized ownership and governance of the data to the domains owning the data. So it's distributed, federated ownership of the data. We're pushing it out from the central IT out to the actual business units, the domains themselves. We're also moving away from centralized architecture, which is owned by IT, where they own the data warehouse or the data lake, to moving out to a distributed architecture, where the data stays in the domains, where it's been built, where it's been managed, where it's been owned. And we move away from building data pipelines to actually delivering data through data products. And the second attribute is data products themselves. So the domains take responsibility for their data. They take responsibility for the quality of the data, the accuracy of the data, and they agree to expose this data as products. They're going to build data products and expose it through standard protocols, standard APIs, etc., so that everybody can then access it. So a data product is really just an agreed upon standard API. We'll talk a bit more about it being discoverable, understandable, secured, and usable in the next slide. So we agree to expose the data through these interfaces, standard protocols, standard APIs, etc. How we actually build them is hidden from the consumers. You don't care how I build that data product as long as I deliver it to you as agreed. If I have 150 hamsters running on a little treadmill to go and power my computer, you don't care. If I use the latest tools and automation to do this, you don't care. It's my responsibility to build the products and deliver the data. You just consume the data I'm delivering you through these standard APIs. Now, the self-serve data platform is actually the fundamental underpinning of a data mesh. This is actually what makes it all possible and actually makes it all manageable. The data platform should be predicated upon the data is distributed. So it has to be a distributed architecture. I have seen people, if you go to YouTube, you can see videos of people who have built a data mesh on a data lake. And they talk about how they built all these data pipelines to ingest the data into the data lake, and then they miraculously turned it into a data mesh. It's not a data mesh. A data mesh is based on the data is distributed. If you're putting everything into a data lake, you're building all the data pipelines, you're doing business as usual. Again, you're just putting a fancy wrapper and saying, oh, look, if I paint my car gray, it suddenly becomes a BMW. It's not. It's still a Toyota Corolla. I wish it was a BMW. So the data platform assumes that the data is distributed. It actually provides the tools and the technologies for the domain subject matter experts to actually build their data products. So it is very, very foundational technology. The key here is that the data platform needs to be controlled by central IT. This may be breaking away from the idea that everything is distributed. And it is, in some ways, breaking away from the purity of the data mesh model. But there's purity, then there's pragmatic implementation. Now, Zhamak Dangani would probably tell me off for saying that you have central IT owning the data platform. But when we come back to pragmatic elements of how do you enforce security, governance, etc., across all of your domains in a consistent way, you need some sort of centralized control plane. So what I said then is breaking away from the orthodoxy of a pure federated data mesh. And we'll look at that in a future slide when I talk about the different types of data platform models you can have. This is breaking with the orthodoxy, saying that you have a centralized control plane. But I have seen organizations implement a centralized control plane, a centralized data platform, and build a data mesh model, and it actually works very, very well. Just because we have distributed data ownership, federated data ownership, doesn't mean to say that we have to have distributed control, distributed security as well. That's where you get into a real mess. If you assume that the different domains and their subject matter experts understand security policies, governance policies, and will implement them all uniformly, you are taking a big gamble. And if it's PII data, you're taking a big gamble, which could get your company into a lot of trouble. So that's why I always argue that centralized control is actually very critical. Federated computational governance. It sounds scary, but it's actually very, very simple. All of the data products that are being built have to be usable. They have to be interoperable. I have to allow other domains to access the data that I am exposing through these data products, and you want these data products to be combined to build higher level data products, which will actually address business problems. So we need some sort of standards. So this is really some sort of agreed upon standards that we will use for our data products. Sounds scary, but it's actually very, very simple. So if we look at the comparison between the traditional ways of managing and delivering data with the data mesh, you can see that we're actually moving from a centralized organization, centralized control of the data, copying the data into a centralized repository, to a decentralized, federated model of ownership where we have distributed data, and we're not trying to copy it into a central repository. We have standards. We're moving from standards and governance that is enforced centrally to a federated model where everybody is actually agreeing upon the standards and agreeing to comply with those standards. And finally, we're moving from the concept of building data pipelines to ingest the data into a centralized repository to building data products and sharing data between the different domains. So again, ownership stays with the domains. They actually share their data through data products instead of actually passing ownership across to centralized IT. So now if we look at how you actually implement a data mesh using data virtualization as a foundational technology, we need to remember that a data mesh is an organizational concept. It's an organizational construct. And we really need an architectural construct to underpin this, to make it actually real. And this architecture must support distributed data. It must support the distributed ownership of that data and the building of data products, the sharing of data products, but keeping some sort of centralized control so you can ensure that you have standardized security policies, governance policies, etc. So you have your data platform. On top of that data platform, or within that data platform, however you want to put it, the domains have their own walled-in area where they actually have control. This is where they can actually build their data products. This is under their control. Within each of these domain sandboxes, whatever you want to call it, the domains can connect to the data sources that they need to connect to. They can go and combine the data from these data sources and build the products that match the entities that they have in their domain. So if you think about this, you could have a customer domain. And in there, The domain subject matter experts can connect to maybe a data warehouse, maybe a CRM system like Salesforce, a marketing automation tool like Marketo. They can combine the data and expose that as a customer data product, which means that everybody can come and use that, access that data to find the accurate data about customer. So the domains allow, the data platform allow the domains to actually connect to the data sources, build those data products. It also allows them to expose those data products so they can be shared and accessed by other domains. So you can build those higher level domains. And then finally, you have a central team, a center of excellence, some IT administration role or something like that, that can enforce security policies across the domains. Again, that's very, very critical. You have a centralized control plane. So creating data products. The data platform needs to support drag and drop, point and click tools to make it easy for the domain experts to build their data products. Connect to the data sources, define how that data is combined, and then published, exposed through those standard APIs, standard protocols to actually create those data products. So again, the example I gave before, the domain subject matter expert in the customer domain can go and connect to that CRM system, connect to the data warehouse, connect to that marketing automation tool, combine the data and expose the data as a customer data product. Other domains can then connect to that and go and get the customer data, knowing that it's accurate, it's trusted customer data, because it's coming from the subject matter experts for the customer domain. I mentioned earlier that the data products need to be discoverable, they need to be understandable, they need to be secured, and they need to be usable. For them to be discoverable and understandable, we need some sort of data cataloging capability. And the data catalog has to take two forms. You've got to have a human readable data catalog because people want to browse and look around and have a look at things. They'll want to look at the lineage of a data product. They'll want to go and look at relationships between data products. So we have to have some sort of data catalog that people can go and browse because people like to know what data they're getting. You also need that in a programmatic form as well, so that I can actually go and get and understand the metadata, the schema, the relationships between these data products. I can do that programmatically. So you want something which is nice and easy for humans to use, but you also want APIs. So it's sort of like the Open API Swagger standards so that they can be discoverable programmatically. Federated computational governance again, flexibility without control will give you chaos. So you need to have control. You need to have some way of enforcing governance, enforcing security standards, security policies. If I want to mask data, if I have PII data and I want to mask in a consistent way, I need to be able to do that uniformly. I can't trust or rely upon the domains to do it properly themselves. Somebody will get it wrong. And then all of a sudden, I go and do something stupid, and I have the European Union, GDPR, coming onto me like a ton of bricks because I've started exposing consumer data, PII data. You need to ensure that it's managed centrally. Now, there are different types of data platform models that you can have for a data mesh. You can see them on the screen there. On the left-hand side, we have the fully federated data mesh platforms where every domain is truly independent. In some ways, this is the pure model. This is the purest model. Every domain is independent. There's nothing shared between them. They all make their own decisions about how they want to build their data products, etc. And then they expose them according to those agreed upon standards. And if you want the data products, you want to access the data products from another domain, you connect to that domain. That might work if you have truly independent domains. It could be in different geographies where they have to be independent entities for legal purposes, etc. But it is a very pure model in that one. Most implementations of data mesh that I've seen are on the right-hand side, the governed mesh. This is where you have that control plane that is owned and managed by central IT or the center of excellence. That way they can apply those consistent governance security policies, but the domains have the ability to build their own data models, their own data products. Nobody's constraining them from building the products, we're just applying consistent, uniform security and governance. And that works very, very well because you have the flexibility with the control. And just to drill into that a little bit deeper, you can see here we have this concept of common infrastructure managed by the Center of Excellence, managed by central IT. They actually manage the connections to the data sources. These connections to the data sources, they need to be secured, they need to be optimized, etc. You don't want anybody connecting to your SAP ERP system and just hoping it works. You need some sort of control there. And that's what the Center of Excellence provides with the common infrastructure. Also, applying security uniformly, applying those governance policies uniformly within the central IT services. And then on top of that, your domains can go and build their own data products, using the capabilities, the tools provided within that data platform. This actually is a diagram I took from one of our customers who actually went and built they never called it a data mesh, but that's effectively what they did. They built a data mesh. But again, the centralized control of that control plane gives them the comfort that they know they're doing things properly, but the flexibility and the freedom for the domains to go and do all the stuff they need to do. Other additional capabilities of using this type of approach: reusability, you maximize reusability. Polyglot consumption, allowing the consumption of the data products through many, many different protocols, APIs. Not just SQL, not just REST APIs, you're going to need both. You may need REST APIs because you want to support operational use cases. You may want SQL APIs because you want to support analytical use cases. You need more than just one of them. You need a lot of them. So, takeaways. Data mesh is very, very popular. I was just saying to Robert that I was in Singapore last week talking to a large government organization about how they can implement data mesh. I was on a conference call with a very large computer manufacturer in China who was talking about how they could implement data mesh. I was in Australia the week before that talking about a company talking to a logistics company who want to implement data mesh. So it's not just North America, it's not just Europe, it's around the world. People are really talking about data mesh. It really does change how we manage data, moving away from 30 years worth of trying to do the same thing but not quite getting it right. And using data virtualization as this foundational platform, it actually adheres to the principles of data mesh, distributed architecture, distributed control, distributed data ownership and building those data products, but centralized control to give you the ability to move forward with the data mesh, but still feel safe that you're keeping control. And with that, thank you very much, Robert.
Any questions in the room? There actually were two questions. I think we have time for at least two questions, and there were two from the online poll. One which I found quite intriguing, which says, according to recent Gartner hype cycle, data mesh comes under obsolete category. So, given all these conversations you've been alluding to, and what's your take on this? Okay, there's a very, very cynical answer to that, and then there's a non-cynical answer. I'll give you the cynical answer first. Gartner did not come up with the concept of data mesh. Therefore, they don't like it. And also, it goes somewhat against their idea of, they're trying to sell the concept of data fabric. Data mesh, actually, I think data mesh builds on top of a data fabric, but if data meshes becomes an accepted architecture, an accepted model for managing data, it makes Gartner look a bit like they've missed the boat.
So one thing is Gartner didn't invent it, therefore they don't like it. Not invented here syndrome. And they do not like it. I have seen their rebuttal of data mesh, and I sort of look at it and say, you don't like this. You're upset because somebody else came up with this. That's one cynical part of it. The less cynical view is data mesh. Zhamak Dehghani talked about data mesh back in 2019, so it's only really 3 years old. It's still maturing. To say it's going to be obsolete when it's still maturing and being defined, I think is a bit premature. And I think that's somewhat defensive from Gartner. So that would be my answer. They didn't invent it, therefore they don't like it.
Okay. I think we're at time, so.
Yeah. Thank you.